Hello, can you hear me? Yeah, great. So if it wasn't obvious, the Wikimedia Foundation is responsible for Wikipedia. So that's the main website we host. And as part of my work on the performance team, we do a lot of monitoring performance from different angles. And a big source of information from us is real user metrics that we collect on people's browsers. So I call this the RUM monster because it's this big pile of data is actually very difficult to make sense of accurately. So that's what I'm going to talk about today. So first, what is RUM data? I'm going to share my own definition of it. So it represents all the metrics that we can collect without user action directly from visitors on their browsers. So I'm only going to talk about web stuff today and not native apps. We do this both on mobile and desktop, of course. So the way you make this happen, typically, is to use client-side APIs that JavaScript makes available, such as navigation timing or resource timing. Those are collected at the browser level. Those are metrics that you get for free that the browser gives you when a page loads. And then typically you'll send that to an endpoint, either something you control yourself or a third-party service that does this kind of thing for you. I'm going to speak about things mostly from the perspective of doing it yourself, because for privacy reasons, Wikipedia does its own analytics. We don't use a third-party provider because we care about your privacy very much. And so we host everything and do everything ourselves. Something that's quite new is custom RUM metrics. So it used to be that most of the JavaScript APIs expose like single scores, like how long it takes for a page to load, how long it takes for the first pixel to appear on the page. And that's not necessarily tailored to your content or your website. So there's an example of something we started doing ourselves recently, which I haven't heard other websites doing. So there's something that we've been struggling with recently, which is that the environment improves by itself. Year over year, people get faster devices, and the network gets faster too. And so when you collect just how long it takes for, say, the first pixel to appear on the page, a lot of that year over year is improving just because people get better devices and the network is getting better. So it's a challenge for us to try to figure out, like, what's our responsibility in that improvement? And are we missing out on some of it? So devices is something we got interested in. And so we started doing a micro benchmark in workers, which are not to be mistaken with service workers. That's a different technology. Workers are fairly old. Basically, the idea is they can run some JavaScript on a separate thread. So it's not blocking. It's not on the main thread like most of JavaScript that runs on the clients. And so we run really very tiny benchmark that doesn't do much just to get an idea of the available CPU power on the device at the time. Because we've seen when comparing this to, say, user agents, like on Android, you can get pretty detailed information a lot of the time about which device you're dealing with. Between two identical devices, same brand, same everything, you can have huge differences in terms of performance. And some of that comes from battery level. When your phone starts running low on battery, it will reduce the frequency of its CPUs, and it will run slower, much slower. And so if you just look at user agent information, you might not know at what state that device is right now, and maybe it's going to be running a lot slower than you would expect for that kind of device. There's also device clutter, people having a lot of apps running in the background, this sort of thing. So this micro benchmarks allows us to kind of get a better idea of how powerful the device is at the time the page load happened. And so it allows us to kind of put into perspective the metrics that we get from the performance APIs. And another new exciting thing that's come out recently, is still in the works, is element timing, which allows you to measure exactly when a given DOM element appears on the page. That sounds very basic, but the JavaScript APIs that supported performance measurements did not do that until recently. So exactly, this is a very fast evolving field. There's new stuff all the time, so I'm going to talk about some new APIs that are either freshly released or in the process of being released, and that are being worked on in terms of standards. So there's layout stability that's being developed by Google. What's exciting about it is it's measuring an aspect of performance that was ignored until now. Like a lot of the existing APIs tend to focus on the initial page load. And this looks at whether or not things stay visually stable as the page constructs itself, or even later. Like sometimes you might have pop-ups or things that appear on the page that push down content, and that's what it looks at. And so we participated in the origin trial that Chrome does. So this is something that's very interesting. It allows you to run APIs that are currently in development on real users, on real traffic. So we've been doing that a few times over the past year to try out those new APIs before they're finalized. And so we can give some feedback to people working on those standards to make them better and to make them do the kind of thing that we expect them to do. We actually found a couple of major bugs in the implementation and that have been fixed since, which means that when that API is really released, it will do what we want. So it's something to consider, like you can experiment on real traffic with this. Event timing is another interesting new API, which allows you to figure out when your event handlers are too slow. So imagine you have an event handler on clicking, scrolling, whatever, any user action on your page. Well, sometimes your code running on the main thread is going to be too slow, and that's going to result in the experience feeling janky, like or unresponsive. Like you're clicking on something and you can't even scroll the page while the event handler is running. So we also did the origin trial, and we found significant bugs on the mobile version of Wikipedia that we could not detect before. Like, it would have required a lot of work to detect those kinds of phenomenons before, and that API makes it very easy to detect. So that's also interesting because it's looking at the performance beyond the initial page load. It looks at what happens when people actually start interacting with the page. It could be much later. Like maybe it's 10 minutes into their session if you're dealing with a single page app. And then maybe something is slow in a given click or a given scroll or whatever. So element timing, I've talked about it. It's also very exciting because it's the first time it actually looks at when something appears on the screen for real. It's not just when the browser adds it to the DOM, which is very common in previous older APIs. Now you really know when the pixels hit the screen and the person has seen the particular element. And so we tried it out too in the original trial, and we found that it differed from first paint. And for us, first contentful paint is pretty much the same as first paint most of the time. So it was different 25% of the time, which means it's adding a new signal. It's giving us some information that's novel. So it's also something we try to look at when new performance APIs come out, is how much correlated is it to the existing ones. Like, there's no point measuring every single new metric that comes out if it doesn't add signal to what you're tracking. In this case, it adds some signal, so it seems worth looking into. So that sounds great. Then a lot of APIs, a lot of technologies to measure performance, a lot of abilities to look into what users are experiencing. So you might wonder, what's the problem? Well, especially when you do it yourself, and that also applies, I guess, to the providers that might do that for you. There's a lot of funny stuff coming from user agents. This is a real example of, like, I looked at what extreme values we were getting recently. And I had a user agent tell us that it took 49 years to load a page on the site. So I'm a bit skeptical that this really happened. So you really need to be careful. I mean, at the end of the day, you're trusting data that comes from random clients. They could be bots. They could be anything. So you really have to pay attention to filtering before you act on that data. Because even if you're using percentiles, this is going to make your P99 shoot to the sky if you're not careful. And if you're looking at averages over long periods, it might look like you had a regression. We just had one crazy value that snuck up in there. It's also quite challenging to do this well over a very long period of time. When you're looking at performance on the website, you want to be able to compare to previous years, previous week, and sometimes things are just going to mess up. Maybe there's going to be a new browser update that breaks an API, and it takes you a few days to respond to that. And as a result, we might end up with gaps, such as the most recent one we had in March. We lost a couple of days of data on that particular system. And again, if you're using a third party, you kind of, trusting them a lot that they get that right all the time, every day, every hour of the year. Uptime is very important for those monitoring systems if you want to have the ability to compare to previous performance. And it can also be quite challenging to isolate causes. So, for instance, the top graph here is that we had a project to reduce the size of blocking JavaScript that we had in the head. So the most critical JavaScript that has to run, that blocks the running of the page before the HTML. The thing you want to be as small as possible because it's just blocking the user experience before people can actually see what's on the page. So we had a big effort, Amir participated in that as in the audience, to reduce that. And so we knew for a fact that doing this must improve performance. There's no two ways about it. It's something that runs in a single thread, and you're making a part of it smaller. It should be faster to load. And so we were expecting that when we released that particular big saving, that it would result in a performance improvement. However, in the bottom graph, you see a performance metric timeline, and lower is better. And the dotted line is when the change above was launched, and performance got worse. And why is that? Well, the explanation is that we have a weekly release schedule to production, and so we don't just launch one thing. And unfortunately, at the same time as we launched this performance improvement, a bigger performance regression launched as well. And so you want to you want to have the ability to launch improvements on their own, to really check if they were improvements, et cetera, or you might have to roll back. Like, you have to be really careful with what's happening at the same time. Like, you have your SREs changing network settings, and all sorts of things happening, especially if you're a big organization. It's very hard to have something that's isolated in time. It's the only thing that happens, and you can check whether it had the effect you thought it would. So that's one of the challenges we have with real user metrics. Another one is that the composition of your audience is very different. And this might come to a surprise, but even between languages on Wikipedia, you have big differences. So let's look at the first two lines. It's desktop versus mobile. So this you expect to be different, of course. For example, market share of a particular browser can be hugely different between desktop and mobile. The CPU benchmark that I was talking about, where smaller is faster, of course, mobile devices tend to be slower than desktop devices on average. Same for available memory. But the thing that may be surprising to a lot of people is that if you compare something like Spanish Wikipedia and French Wikipedia, which are technically very, very close. There might be minor differences in the plugins they have installed, but for the most part, we're talking about the same website. And then the Firefox market share, for example, is hugely different between those two languages, and so is the median score for CPU performance and available memory. What that means is, if you look at the performance metrics for Spanish Wikipedia and French Wikipedia, if you're looking at them globally, you're comparing apples and oranges, because the mix of devices and the mix of user agents is completely different. So that also applies to you if you're comparing yourself to, say, competitors. Maybe they don't have the same kind of audience as you in terms of capabilities. So if you're just looking at, say, your total load event end or your total first paint compared to a competitor, well, maybe it's not a fair comparison because you're not dealing with the same population of users. And to make that even worse, so this is why this monster is shape-shifting, this mix changes with time. It changes with the day of the week, it changes with the time of the day, and it can change over long periods. Like these colors is like a breakdown of market share of different browsers. I didn't label them on purpose, but you might guess what the biggest one is. And you can see that if you look closely, maybe that those trend lines change a little bit over the course of a year. And that's also something to keep in mind when you're comparing your own performance from last week or from a year ago. Well, your population is not the same anymore. So that's also another complexity. Like, you have to be really careful when you're looking at metrics globally. So we did some research last year on how those metrics correlate to what people think or what they express about performance. So we ran a micro-survey on several languages of Wikipedia where we asked people, after the page loaded, was this page fast enough? And I stress fast enough, not fast. We're looking for the satisfaction point. So it was a binary question. They could opt out if they don't want to answer, but we wanted to see when people tell us, yes, this is fast enough, does that really correlate to those metrics that we're collecting from their browsers? And the answer is the correlation is very, very weak. And you might be surprised as there's very little research that's been done on that before. Like, I did a big literature review, and the reason why we ended up doing this is because nobody did it before. And it tends to be that those APIs are exposed because they're easy to expose. It's cheap for the browser to tell you when the first pixel will appear on the screen, but maybe it's not what users really care about. So you have to be careful when using this as well. It's connected to user satisfaction and engagement, but maybe not as much as we might have thought before. So in that context, it's even surprising for us, at least. I mean, this is all Wikipedia, of course. The one that did the least terrible like in terms of performance metrics up there, like load even end is like considered really old school. It's when everything is loaded on the page, including all the images that you don't see, the ones that are below the fold. Like common knowledge in the performance community is that, well, you should only look at above the fold, speed index and all that stuff only looks at that, when in fact, we kind of see the opposite in this study. And then it suggests that people care about what's below the fold more than we might have thought before. I think as an industry, those APIs have been focused a bit too much on the initial page rendering. So I've talked about recent new APIs that go beyond that, but historically, things like first paint, first contentful paint, navigation timing, have all focused on the first rendering of the page. And if you think of the person using your website, they're not going to stop at the first 500 milliseconds to judge the experience. And most of the performance metrics that people have been focused on only look at that very, very first part of the page rendering. So yes, first impressions matter, but maybe it's time to also look at what happens afterwards and how it informs people's opinion about performance. So there are some new ones or some that do both, but even the ones that do both, when you look in practice at how people use them, they tend to mostly look at the initial page load, or anything that happens before the load event. So I will try to give you some practical advice from things we've learned. So it is useful to keep one of those or a couple of those very popular metrics, even if they're not good, for one simple reason is that this is what you will be judged by, especially by search engines. The reason why Google is pushing hard on new standard performance APIs is that they need a stick to be able to measure every website out there. And so if Google is advocating for a specific performance API very strongly, you can kind of guess that they're probably using it in their search indexing. And so it might be worth for you to keep track of that for that reason. If you care about your search engine ranking, you should care about those popular performance metrics that you can collect from visitors. But I think that for your user experience, you should really look at what people are trying to do on your website and adapt performance metrics to what you're trying to achieve, to the conversion you're looking for, to the user behavior you're expecting, et cetera. And with these new custom metric APIs, you can do that. Like maybe you're looking for a specific call to action, so you want to know when that renders. It's more important to you than when the first pixel appears on the page, for example. And I think it's also very critical to capture very different aspects of the user experience. Don't stop at the initial page rendering. Look at event handler slowness, long tasks, et cetera, that happen way after. Because it doesn't really help to measure like 10 different paints that are all very close to each other. They'll be highly correlated, and you spend a lot of effort measuring things that are, like a few dozens of milliseconds apart from each other. Just kind of pointless. And I encourage other organizations to do more research. There's really a big lack of research in that field, of understanding what people think of performance. And if you do like we did, you might be very surprised in the results. Like we really didn't expect to see that outcome in the metrics that correlated the best. So very important, I mentioned before, there's a lot of junk coming through. As much as we get 49-year page load, we also get 0 millisecond page loads. That's physically impossible. They're not running in our data centers. We also get negative ones, people traveling in time, apparently, to load our web pages. So you really absolutely need to filter the data that comes in that way. We've also discovered 2 phenomenons. So we know that, for example, Boomerang, which is the most popular open source library to do this kind of thing, takes that into account, but we don't know if the commercial products out there that help you measure performance do take that into account. So we've discovered a few years ago that backgrounded tabs tend to really have strange performance metrics. The reason is that browsers tend to put them to sleep more and more aggressively, and if the user puts your tab to sleep as the page is loading, when the user comes back to it, it will finish loading much later and you get really strange values. So by any means, if the page was in the background at any point in the page load that you're trying to measure, discard the data because it's going to be full of noise and probably invalid. And for the same reason, we also filter out page refreshes. Same thing, weird stuff starts happening with timing APIs related to performance when you refresh the page. And this information you can get from the navigation timing API. question the pipeline. That's very critical. If it's your own, of course, you have to really do a lot of monitoring and checking to see that it's correct. And if it's someone else's, you really need to question their quality of data processing. So this is our pipeline. See how many steps there are for the data to travel through, from all the way to the left, their web browser, and all the way to the right when you actually plot the data you have. Many, many mistakes can happen in the middle. You can lose data. Maybe one user agent that's not very popular updated itself, so maybe it's like 1% of your traffic or less, and it broke an API, and suddenly you're not collecting that anymore. Maybe you don't see it in the global metrics. So if you're not paying attention to every single user agent, you might suddenly be losing data. You realize it much later because it's some obscure, older version of a browser that is affected. Things can be lost in transit, et cetera. And then very critical as well is your own storage, and also how you visualize the data can be quite misleading if you're not careful. Like, people tend to stop at the default dashboards that are provided, and a single view to understand this is really insufficient. So that's where I'm getting at. When you get data, you want to zoom in and zoom out. For instance, you might be really focused on, say, weekly time frames, because you deploy things once a week. And so we have a lot of dashboards like this where we compare 1 week to the previous week. So the green line is the current week, the orange line is the previous week, and the higher it is, the worse it is. It takes longer to load pages. So you see this happening, this might trigger an alert. You're like, whoa, our time to load a page has increased by 100 milliseconds. It's huge, maybe 5% or whatever. And you might overreact, start investigating, and so on, when in fact, zooming out at the year level shows you that maybe it's actually just noise. And we've been improving significantly for several months, and there are organic spikes that have to do with, again, the mix changing. For example, imagine there's a very big event in a part of the world where the internet is slow, and a lot more people come to Wikipedia, then suddenly the global metrics are going to look worse, because we're getting a higher amount of people that have slow internet connecting to us. And this kind of thing happens all the time because of news, and this applies to a lot of different websites. We're talking about e-commerce websites having sales, going to attract a different crowd than usual. And so you really need to put things into perspective. When you see something happening on a small scale, you need to look at the bigger scale to see, like, does this really matter? It makes alerting kind of challenging as well, because, yeah, you have to do some manual checking when alerts go off. You need to look at things from different angles as well. You might have surprises. For instance, this is an example. So imagine you only have the top graph, which is similar to the previous one, and just looking at the time it takes to load pages. Well, clearly something is going wrong here, and we have a big, big spike in the time it takes to load a page at a specific time. Again, if you kind of overreact, you might start looking at code that was deployed and so on, when your reflex should be to start looking at the data from other angles. In this case, look at the report rate, and this is how often we get those beacons of data from users that report the performance timings. And we see that there are huge dips around the same time. And this suggests very strongly that it's a networking problem, as in people not only having a slow experience, they're having trouble connecting to us because we have big dips in the traffic that we should be getting. And so again, you want to look at not just the metrics, but also how often they're getting reported, and slice them if you can. And then looking still at the same event, we're looking at this time, same metric, but per country, and we see that different countries are affected at different times. So these networking issues did not affect people equally in the world. And so that's also something to pay attention to. Maybe something that happens in a place where you have a lot of users will look amplified, and equally something that happens in a place where you don't have a lot of users might be invisible in the global graphs. So yeah, you need to slice things up, and you need to do that in advance. If your graphing capabilities do not allow you to go back and slice the data according to different criteria, then it's kind of impossible to figure out what the source of the problem was. So it's not just about being able to set this up at some point, is that you need to have this set up from the beginning so that when you actually need to slice data up, you can do it. Like we've had many cases where we just didn't have the ability to go back and slice it by a criteria that we're interested in. And so that's very, very critical. You want to have not just specific metrics that you've thought of setting up, but really think of the different scenarios that can happen and slice them by different criteria that will be useful later when something might occur. You can even look at specific profiles. If you know that some users matter more on your website than others, say you're an e-commerce website, maybe your big buyers are, have a different kind of profile, maybe they use different user agents, different devices, you might want to focus on that because that's more critical to your business than other visitors. But the drawback of this, though, is that you're dealing with less data, so it's more noisy. And something that's fairly new, if you're big enough, but they're lowering the threshold more and more, so before we get to the point where really most websites can do that, you can compare yourself to others. Those real user metrics are now available for any websites you want, thanks to Google's thirst for user data. So whether you know it or not, if you use Google Chrome and you have the sync feature enabled, which means that when you go from one device to another, you have all your bookmarks and your logins working, well, anytime you visit websites, you send performance metrics back to Google. And they make that freely available for all of us to use. And so you can start comparing yourself to other properties. In this case, I compared Wikipedia to Google. So we're doing, the top two ones are desktop. So in terms of desktop, we're doing okay, we're doing better than Google. But on the mobile site, we could be doing better for first contentful paint. And so you can see this for many different end user performance metrics. It's always aggregated, of course. You can't like slice it and find a specific user, but you can get data, like it's published every month. So that's called Google Crux, and PageSpeed Insights is like a simplified view of Crux. And there's a lot of digging around you can do. It's quite useful to really figure out where you stand in terms of quality of your website. Like you might wonder, like, are we doing well? Are we doing, Google level performance? Then you can find out with that kind of data. And even for yourself, it's always like a good safety net, as in if your own monitoring is messed up, then you can compare it to that, or even for sanity checking. Like when this came out, we went and checked our version of that data, tried to compile the same values as they do, and compare it to theirs, and we saw that it matched reasonably well. So something to keep in mind is that it is only Chrome users, so that's not necessarily representative of your crowd. If Chrome is not necessarily the most dominant browser everywhere in the world, so depending on who's coming to your website, it might not be significant. Chrome users tend to have faster devices, and in this case, people who use Google Sync might be a bit more tech-savvy. So it's a lot of things to keep in mind. It might not be representative of the visitors of your website as a whole. And that's it. I wanted just to point out that we are hiring a systems performance engineer for our team, so if you're excited to work on that type of stuff, take a picture of that link and please apply. And we will be running a web performance track at FOSDEM in Brussels on February 1st and 2nd, focused on open source tools, research, and open standards. So by all means, if you want to speak about performance, web performance, do apply. Any questions? Thanks.